Welcome to forest gardening. Forest gardening may sound like you're gardening in the forest, but our goal is to mimic the forest structure and ecosystem patterns to enable us to create abundant harvests of low-maintenance fruit, nuts, herbs, roots, shoots, and medicinals. Forest gardens can provide many yields for human habitats, including food, fuel, fiber, fodder, fertilizer, pharmaceuticals, and fun. Let's take a look at each of these yields in context. Forest ecosystems can provide a diversity of food plants such as fruit, nuts, berries, roots, shoots, tubers, herbs, and mushroom crops. In a forest garden system, there's an abundance of food for both people and wildlife. Over time, the system becomes more self-maintaining as the plants mature. Many food plants are not available in conventional agriculture and can find a place in the forest garden where they can be transported and consumed locally. Firewood harvests in cold climates can be a key component of a forest garden, and one system that has a lot of potential in this area is known as coppice agroforestry. In a coppice firewood system, trees are cut a few inches above ground level, and the stump resprouts with straight poles as shown in the photo on the left. Poles are cut at 5, 10, or 15-year intervals and provide the correct diameter logs to use as firewood. 1 cord of wood weighs an average of 4,000 pounds, so the more wood you can grow close to where it will be used, the better off your back will be. Fiber plants produce plant fibers that can be made into clothing, rope, paper, and baskets. There are fiber plants that can be grown in nearly any climate. Some common fiber plants include willow, flax, mulberry, and bamboo. Fodder plants are grown specifically to feed to livestock animals. Forest garden plantings of fodder can reduce feed costs for keeping livestock. Packaged livestock feed often contains large amounts of GMO corn and soy, and it is often transported many miles to get to your feed store. The more fodder crops you can grow as part of your system, the less you'll need to spend on industrial low-grade feeds. Fodder crops should be high in protein and relatively easy to grow. The animal's dietary needs will determine the types of fodder crops that would be suitable to grow. Many nitrogen-fixing and nutrient-accumulating species may be grown as part of a forest garden to provide fertility to the system. The Siberian pea shrub, pictured at the left, fixes nitrogen in its root system and can be cut back multiple times per season to be used as mulch around fruiting plants. This technique is known as chop and drop mulching. Select fast-growing, nitrogen-fixing species to plant next to fruit trees that need more fertility. Cut the nitrogen-fixing plants back 3 to 6 times per season and drop the pruned branches under the fruit trees. The roots of the nitrogen fixers will die back to compensate for the lost branches, providing nutrients underground to the roots of surrounding trees. Some medicinal plants are only found in the rich forest soils of forested regions, such as the prized ginseng root, which grows in shaded, fertile soils. Mushrooms are some of the world's finest medicinals, with actions particularly focused on enhancing the immune system. Take a moment now to review the yields of a forest garden that were just presented: food, fuel, fiber, fodder, fertilizer, and pharmaceuticals. Pause the presentation and create a sketch or journal entry on the top 3 yields that you imagine utilizing at your site. The forest garden has high yield potential due to its layered arrangement of useful plants. Robert Hart, the pioneer of forest gardening, developed what is now the oldest forest garden site in the world in Shropshire, England. His site boasts 7 layers of edible forest garden plants. The tall canopy layer consists of mature fruit or nut trees. The low tree layer is composed of smaller fruit trees on dwarfing rootstocks. The shrub layer is next and can contain fruit bushes such as currants and berries. The herbaceous layer is home to perennial vegetables and herbs. The ground cover layer hosts edible plants that spread horizontally. The rhizosphere, or underground layer of plants, grown for their roots and tubers, is next, and the final layer is the vertical layer of vines and climbers. The edge of 2 habitats is the most productive and diverse due to the increased numbers of available niches for plants and animals to occupy. Edges can be found where forest meets meadow or where meadow meets pond. Strive to create as much edge as possible in forest garden systems, and you will be rewarded with an increase in biodiversity. Succession refers to the change in plant communities over time. Plant communities change after any disturbance in predictable ways. First, grasses and annual weeds cover the landscape, making it possible for perennial herbs to take hold. Soon, shrubs and pioneer trees will follow until the tree canopy closes, creating a mature forest. A shift in species occurs during the successional phases. Plants use different successional strategies to carve out a niche in the forest. The high-stakes gamblers of the plant world are species that thrive in full sun, grow quickly, and occupy the top levels of the canopy. High-stakes gamblers have a fast growth rate, few reserves, a short lifespan, and high mortality. Examples are birch, apricot, or peach. We can think of species that tolerate shade, grow slowly, and occupy the lower levels of the canopy as misers. Misers exhibit a slow growth rate, larger reserves, a longer lifespan, and low mortality. Oaks and hazelnuts are examples of misers. Oaks start bearing at age 35, with their best crops between age 75 to 150 years old. Hazelnut is pictured in this photo. Some species fall in between high-stakes gamblers and misers. These are the investors. Black cherry and many other fruit trees are considered investors. They have a moderate growth rate and lifespan. Now it's time to review succession. Draw a comic strip of what your yard would look like if you stopped mowing it. Each panel should take you through time from the present to 5 years, 10 years, 25 years, and 100 years from today. Here's an illustration of how an old field may transition into a mature forest. The key is to remember that succession is a constantly evolving cycle of disturbance and regrowth, with no real beginning or end. Let's talk a bit about carbon sequestration. Industrial annual agriculture destroys soil structure and texture through tilling and also releases large amounts of carbon into the atmosphere. Perennial woody plants found in forest gardens can sequester more carbon in their tissues and remove it from the atmosphere, storing it in their biomass. Here are a few examples of forest garden plants. Most fruiting trees or shrubs in the forest garden are planted with an array of plant allies that help build soil fertility and cycle nutrients through the system. These allies may fix nitrogen or mine the subsoil for minerals, or they could be nectary plants for attracting insect pollinators. If there are some plants here that you've never heard of, you may want to jot them down in your notebook to research at a later time. What does a forest garden look like? The next few slides will present forest gardens in different contexts and climates. Here is an example of a forest garden from London Permaculture. You can see many of the forest garden layers in this photo. This highly manicured garden contains trees, vines, and ground covers that could easily be adapted to grow more diverse food plants. The key to the success of this landscape is that it's a functional outdoor room. Oftentimes, landscapes that are lived in the most function the best. The circular beds of the mandala garden allow for the greatest amount of surface area for planting with the least amount of area for weeding. Mandala beds can be arranged to have a central planting of one dwarf fruit tree surrounded by support species. This miniature forest garden has one fruit tree surrounded by plants that build fertility and offer additional yields. The design mimics the patterns of forest gardening on a micro scale. Some permaculture designers are moving away from the typical forest garden model as a collection of patches of trees to a model called linear food forests, which are planted on contour swales. This model allows for much easier maintenance and management because fencing, irrigating, grazing, and harvesting all occur more easily in straight lines. Using swales to reduce the need for irrigation, because the swales capture water and infiltrate it into the soil uphill of the fruit trees. The swales that are pictured in this image are hugelkultur swales, which means that woody material was buried at the base of the berm. The wood acts like a sponge to store water, and the nutrients create a more fungally dominated soil that is preferred by fruit trees. We've only just grazed the surface of forest gardening. This forest garden pattern language identifies over 60 patterns that can guide us as we design and create forest gardens. Which patterns jump out at you from the slide? Choose a few forest garden patterns that you might apply to your particular site. Restoration agriculture. Mark Shepard's 100-acre permaculture farm produces forest-derived agricultural food products that feed people on a large scale, while also restoring the surrounding landscape. He calls his practices restoration agriculture. Only biological systems of trees, shrubs, herbs, roots, and shoots, in collaboration with other organisms, generate greater yields over time, with food forestry and restoration agriculture leading the way. If you're ready to start working on your own forest garden, here's a checklist for beginning a forest garden project. Step 1 is to identify your biome. Look to nature to mimic which food-producing species will do well in your area. Next is water management and earthworks. Newly planted trees require up to 5 gallons of water per day for the first month or two of planting, and then 5 gallons every few days for the next few months. Be sure your forest garden has multiple water sources. Next, establish perennial polycultures. Trees and shrubs form the backbone of the garden, and using a diverse mix of varieties is key to find out what grows best in your climate. Next, build roads, fences, and utilities. Also, you can establish agroforestry practices. Research agroforestry practices that may make sense in your area. And lastly, manage for eternity. Create a system that keeps producing food for millennia. Thank you for listening.